All right, so this is a bit of housekeeping. So what I'm going to do is I've got this presentation that I'm going to be giving to you, okay? And it's all about the HTTP protocol and how HTTP works, and specifically how HTTP works with the ESP32. Now, what I'm going to be doing is I'm going to be focusing very much on the presentation and also on some of the demos that I'm going to be doing, right? And in the downtime, like when I'm actually trying to flash the chip or what have you, then I'll be sort of looking at the chat, and if there's anybody got any questions, please feel free to ask at that point, and then I'll go ahead and answer any questions I can, okay? I'm going to try and get through this in a speedy manner. I don't want to spend too long on it. So, you know, like there's a lot to cover. So what I'm going to be doing is I'm going to be doing my best to make it as efficient as possible. All right, good. So let's get started, guys. So welcome to this presentation on HTTP protocol for the ESP32 developers. All right, so this is me, all right? I am the founder of Learn ESP32, and I also have another course called LVGL.Academy. So if you're looking at this for the first time and you don't know who I am or what the ESP32 is, it's a microcontroller that is developed by Espressif. It's a very powerful one, and I teach people how to use it well. I've also got another course on LVGL, which stands for Light and Versatile Graphics Library, and this particular course over here teaches you how to use TFT displays, so you can create graphics for little microcontrollers. So I've got 20 years experience, development experience behind me. I've done all sorts of different things, including document management systems, CMS, web development, and lots of microcontrollers. So I've got 10 years plus experience in electronics, and I've trained literally thousands of people. I did a lot of training in Dubai as well, so I've got a lot of training experience behind me. And here you can see a picture of me with one of my snakes. Yes, I keep animals. I'm a big fan of animals, and I do like snakes as well. So this is my Darwin python. Okay, so if you're interested in learning more about the ESP32, go to learnesp32.com. It's a great way to learn the ESP32. And if you get stuck in this particular some of the demos over here, then you'll probably need to refer to that to see, you know, what's missing, or try and actually fill up some of your knowledge with this course. Okay, so let's get started with the actual HTTP protocol. So why and when would you use HTTP protocol? So, you know, there's a lot of questions. People say, no, you should use MQTT, you should use CoAP, you should use various different things, but there's actually a good place for HTTP and the various different other technologies. So before we get into that, right, let's see what we will be covering. Firstly, we will cover the fundamental concepts of HTTP and HTTPS. Right, then we will be looking at the ESP32 as a server, the ESP32 as a client, and some tools that will help you. So what we won't be covering is creating a web application or exposing the ESP32 outside the network. If you guys are interested in actually learning about that, I can show you how to do that maybe in a future session. We can do like a create React app and basically show you how to do it after the, you know, we could show you how to do that, you know, expose it to the internet. So we can do that maybe next time. All right, so Gartner actually made a comment once. He said that the reason why IoT is not actually working as well as people would hope it would be because there's lack of knowledge in the market. I think that's a little bit of an unfair statement. I'd say that a more accurate statement would be that there's very few people who have multiple disciplines that are required for IoT development. If we have a look at the IoT landscape, we have electrical engineering, we've got embedded development, you need to know COM protocols to be connected to the internet, and you also need to know some cloud services. So right now we're going to be sort of filling in a little bit of gap on this comms protocol in terms of how do you actually communicate with HTTP. So when to use HTTP protocol? It's a good idea to use HTTP protocol when you're acting as a web server, when you're hosting websites, when you're actually trying to serve pages, or when you're trying to serve REST requests, or essentially give information. right? When you wish to retrieve information from the RAID cloud services, in other words, you can actually use HTTP protocol to very easily hook up to AWS, Azure, various different databases, timetables, social media, etc. So, in other words, if you want to do something, let's say, for example, you want to use Twitter, you want to create a Slack message or something on that sort, then HTTP protocol is the best way to do that. MQTT is not going to work for you. All right. If you need a lot of simplicity and infrastructure costs are important factors to your project, HTTP protocol is very good. MQTT requires a broker, so it's an extra overhead. Right. Integrating into existing systems with existing security. So very often you need to actually call somebody else's service to get information. Like for example, if you're working as a client and you want to get somebody's timetable for their buses or their trains, you'll be integrating into the existing systems, and therefore HTTP is probably the best way to go for that. So you should use alternatives to HTTP protocol when data needs to go to multiple subscribers. That's where MQTT really shines. So you got one ESP32 that needs to now all of a sudden communicate to hundreds of others, then MQTT is probably better for you. All right, when validation of your message delivery or quality of service QoS is key, then use MQTT. Or if you need real-time frequent data updates, then you should use either WebSockets or WebSockets over MQTT. So this is essentially when you would not want to use HTTP protocol. All right, so now that we've got that out the way, let's have a look at some HTTP protocols in a nutshell. HTTP protocol is really, really simple if you just take a step back and have a look at what it is. Everybody uses it pretty much on a daily basis, right? But if we actually just analyze what it is that we're doing, we have a client, all right? And a client basically sends through a request, and the request basically responds with a response. And that's pretty much all there is to it. So that's the entirety of HTTP protocol. Everything that we do with HTTP protocol, whether you're actually streaming internet or whatever, or looking at creating chats in the window, you always basically are having a client at some point. A request comes from the client, it goes to the server, and then the server responds to it. Now, one thing that I would like to just sort of say quickly is that when you're actually trying to learn something, right, or when you're trying to actually figure out what data is important, a data is only useful if it's, as it compares or evaluates to other data. So what I've got over here is a bit of a chart of all the things that we're going to be covering, and over here we'll have a look at the relative importance of these facts. So a client sends a request and the server sends a response. That is a 5-star fact. That's a very important fact. Okay, that's pretty simple. Let's leave it at that. All right, so we've talked about the fact that we have a client and a server. Now, we need to basically figure out where that server is. We need to find out what address it lives on. Servers have an IP address. Applications listens for incoming data on a port. All right, and there is a difference between the internal and the private network of an IP. All right, so if we have a look at something like this, what you'll notice is we have a router, and this is, and the router has an IP address, and then essentially we go through from the other side of our router through to our application, which is sitting on our ESP32, and our ESP32 also has an internet address or an IP address, and you can see that that IP address is different to that IP address. Okay, so if I go ahead and actually just bring up a command prompt here, and I say ipconfig, that tells me, right, what my IP address actually is, right? And if I go through to a web browser, and I say, what's my IP, right? What you'll notice is that I'm going to get, it's just checking for my IPv4, it's going to give me a totally different IP address, okay? So it's important to understand that, one of the questions I get is, how do I actually expose one of my ESP32s? Well, you can't do it, and you can't expose these internal IP addresses. You can only expose the external ones. and you have to route those through to the internal ones. But we'll have a look at that another time. The important part of this slide is to understand that your IP address of your chip is different to the IP address of your router. So what have we learned so far? We have learned in addition that servers have an IP address. We've also learned that applications listen on a port. So these are essentially the facts, and we can see their relative importance there. Now, if we want to basically get hold of a particular server, IP addresses are very inconvenient. Right? We don't want to remember things like 142.2.50.70.2.6. So somewhere around they have something called a domain name server. And what this does is it essentially maps a name like google.com to an IP address. Okay, so this particular IP address 142.2.250.70.2.6 is going to equal to google.com. Okay, and if I do something like this, if I say ping google.com, then I can see what that IP address currently is. Okay, so what have we learned so far? Domain names map IP addresses. So, we can see that we're looking at things very simplistically here. We're looking at things in a very, very simple way, right? So a client sends a request and the server sends a response. Servers have an IP address. Applications listen on a port, and domain names map IP addresses. So that's pretty much all we have done so far. Now let's have a look at a URL. Now, the makeup of a URL is as follows. Firstly, the beginning of a URL is a protocol. And when we can have different types of protocols. We can have HTTPS, WebSockets, MQTT, file transfer protocols, etc. So that basically is the first part of a URL. Then we have the optional subdomain. So over here you can see that this is gmail.google.com. We also have things like maps.google.com. Right, but that is optional, but that's essentially a subdomain of google.com. So it's it's like a less important or essentially a part of that particular google.com. Then we actually have the domain, google.com. And this over here, between that point and that point, is actually a substitution for an IP address. Right, then after that comes a port 80. Right, now very often you don't have to put the port 80 in, but we'll discuss that in just a moment. Then after that, we've got a path. It's application specific, and this is also optional. So in other words, what we're actually trying to do is we're trying to go through to an inbox. Okay, and then after that, we've got some sort of query string where we can actually give the application additional information, which comes in key and value pairs. All right, so we use URLs pretty much in our daily lives, right? But if we have a look at that, we can see what this thing is actually made up of. Alright, so we don't always need to specify a port. If the protocol is HTTP, the default is port 80. And if the protocol is HPPS, the default port is 443. So if I go ahead and actually come up to here and put in something like google.com, okay, and you can see there that if I click on this, you can see it's HTTPS. So if I say :443, it still resolves. It's exactly the same thing. If I come in here and say port 80, it's not going to resolve because that's the wrong port. Okay, so what have we learned so far? A URL gives us a unique web address for an application or part thereof. And the reason why we say part thereof is because an application can be listening to multiple different parts. And we can see that's pretty important. All right. So now we get on to the meat and potatoes of what's actually happening behind the scenes. When we're looking at things like the web request, when we're looking at things like the URL, we are, it's very visible. We see that a lot. But one thing that's not quite obvious is what's actually happening behind the scenes. And the first thing that I'd like to basically discuss with you is essentially the method. Sometimes it's also called a verb. And the verb describes what the client request wants to do. So we can see that there are various different types of verbs. So we can see get, so the get basically gets the data. All right, I'll just go through what these are quickly. Head basically just gives me some additional information about the request. Post is a very important one because that allows me to actually push data, or basically send data to a server from a client. All right, so between all of these, the ones that are actually the most common are get and post. And you can have a look at these other ones, and they have their own uses and they have their own functions, but most of the time when you're writing applications, you'll use get, post. Sometimes you might put, or occasionally delete. Options is an interesting one that basically comes into play when you have cross browsers between one browser trying to communicate to a server that's not on the same domain. But we'll basically skip that for now. Right, just remember get, post, and the rest of them are pretty much optional. Right, so more on methods. All web requests have a method that describes what it intends to do. The most common method is get. Oops, sorry, let's go back one. All right, if you don't specify a method in your web request, the default is get. All right, a client can also receive information with a get. If a client wants to give data to a server, it must use a post, put, or patch. So those are essentially other options that you can use. So if you're wondering what the difference is, post will basically send information. Put is usually used to update existing information, and patch is also used to update existing information. The difference between put and patch is put you normally give the entire data and it'll update the entire data, whereas patch you just basically give just part of the data and it'll update just that one piece of data. But most applications can get by with get and post. So, we'll see that in the examples we're going to be seeing, right, get and post are essentially the most relevant. So one thing I just want to show you very quickly, right, if we go back to google.com over here, okay, so at this point in time, what actually happens behind the scenes is I actually ask for an HTML page by going to google.com. It's got a whole bunch of other stuff in there. It's got images and style sheets that it basically recalls out. And I can actually have a look at that by going and saying inspect and then network. And if I basically refresh this over here, you can see all of these methods coming through over here. So you can see we've got one get and a couple of posts, okay? And what I'll do here is just to show you, if I'll go to learnesp32.com, and what I'll do is I'll try to sign in. Okay, and I'll just go ahead and put some xxx@yyy.com, and then I'll put some password in, and I'm putting rubbish in there because you'll actually see what's going on. Right, so what I'm doing is going to just clear this, and I'm going to ask just for XHR. In other words, I'm just looking for information. I'm not looking for pages or anything else like that. And I say sign in. You'll see that there was a post, and you can see that there was an error. But if we go and have a look at that, all right, we can see this is the preview. The user does not exist. Okay, so if I scroll down over here, you can see the request payload, right? This is essentially the information that went through to the server when I hit that. And this was the response. Message user does not exist. So the point being, right, that we can actually sort of get and send information using these verbs. Okay. So what have we learned so far? All web requests have a method that describes what it intends to do. So whenever we try to basically do any web requests, we need to think about what it is that we're trying to do. Are we trying to get information, or are we trying to basically update the server with information? And that will generally decide whether we want to get or basically post. Okay, so here we go. Right, first essentially bit of code. All right, so usually what happens when people look at code, they usually freak out. Don't worry, we're going to walk through this. If you're not used to the IDF code, this is actually pretty straightforward and very easy. Okay, so let's have a look at this. The first thing we do is we actually create this ESP HTTP client config structure. And the only thing that I'm setting over here is the URL. Okay, so we can see that I'm going through to this thing called real-time World Time API org API time zone for Europe and London. So what this is going to do is this is going to actually get the current time in London. All right, and then what we do is we basically say initialize our client with this particular structure. And then what we do is we say ESP32 client perform. And perform does this whole get and request. So it essentially does the request and then waits for the response. That's what that does. And once we've got the response, right, then we can check what the response was. We can get the length of what the content was that was returned. Right, and then over here what I'm doing is I'm just essentially creating a little bit of a buffer to actually keep my information in. So I'm basically getting the length and I'm just saying malloc that, so please give me some space on the heap. Then I'm clearing that out and just cleaning that up, that memory that I just allocated. And then essentially this particular function over here, ESP32 client read, is going to take that buffer that we've just created and fill it with whatever came in from the client. Okay, and then we can print it out. So before we actually have a look at this demonstration, okay, here's a couple of questions, right? What's the domain? worldtimeapi.org. That is the domain. What's the path? This is the path, API time zone Europe London. What's the port? I haven't specified it yet, so it must be the default. And it's HTTP, not HTTPS. So it's port 80. And what's the method? The default is get. I haven't specified it, so it must be get. So hopefully you were able to answer those questions on your own. And if so, then all good. All right, let's go ahead and have a look at this. All right, so here we have this exact same HTTP client over here. So this is essentially exactly what you just saw. Okay, and of course if I go ahead and put this in the browser, it's going to call that API and I'm going to get the time for London at this point in time. So you can see day of the week here. Let's see, where is it? Right, here it is over here. Time 10:21:43. Okay, so hopefully that's right. All right, so now that we've looked at that, let's go ahead and actually try to run this. All right, I'll just show you how to, actually before I get into that and before I actually show you this demonstration, probably a good idea to actually just give you a quick orientation as to how this demo actually works. So over here you can see that I've got various different files over here. So we've got client, HTTP server, HTTPS client, HTTPS server, and so on and so forth. And then I've got here the main function, and the main basically calls a method in each one of those files. But you can see that what we're going to do is we're just going to basically uncomment one at a time and just run that just to basically show that working. So the first thing that this application does is it goes ahead and connects. And this is a very simple connect. I mean, it's probably the simplest sort of connect that you could probably do, where firstly it basically initializes the Wi-Fi, and then it's got a semaphore which basically just sits there and waits for the event handler to basically get an IP address. So once that's actually gotten the IP address, then it's going to basically connect. So again, if you'd like to know more about sort of this sort of stuff, have a look at the modules inside the course. They'll basically teach you all about how to connect to the internet. But once we've actually connected, then we run this task, and then we just pick up the piece of code that we want to actually run. So in this case, this is the HTTP client. And that's pretty much all we need to do. So let's go ahead and run this. All right, and it's going to take about 10 or 20 seconds to run. It's flashing. All right. So we can see that it's waiting to connect. It's got an IP address, and there we have that same JSON that we actually just saw from the browser. So our ESP32 is now capable of pretty much getting any time around the planet just by adjusting that URL. Yeah. So so web APIs definitely have their place, and they're very powerful in this particular aspect. All right. Next. Right, so we've looked at a client. Now let's have a look at a server, because our ESP32 can act as a client, as our browser would normally do, but it can also act as a server, right? And this is really, really simple. So in other words, let's go ahead and have a look at the actual code. So firstly, what I'll do is I'll go to main and I'll just comment this out. And I'll just put that in, and then while we're actually waiting for it, I'll just go ahead and flash it. So let's go have a look at this code over here. To set up a server, very easy, all right? You just need two structures. You need the server structure and you need this configuration structure. Then we say HTTP start, and we pass it the server and the config, okay? And we can see that we're just using standard default config, so we don't really need to do very much. And then after that, what we do is we basically specify this little structure over here. So this is quite interesting. This basically says what the URI is actually going to be looking at, what the application is going to be looking at in terms of its path. Where's the path that we care about, right? What is this? Is this going to be a get? Is this going to be a post? So we're interested in the method. And now we also specify the handler, okay? And the handler is essentially this callback over here. All right. So at this point in time, what you can actually see, while we were actually sort of looking through that, we can see that we've got the IP address and now the server is registered. And over here, we can see that if we visit this particular IP address, right? Of course, we could map that with DNS to a URL, as we've learned. Okay. Then we're going to hit this and we're going to respond. We're going to respond with this hello world message. So let's go have a look at that. I'll just close this. All right, so we'll put this in here. And we can see hello world coming up there. Okay, so far very, very straightforward. All right, let's get back to the slides. All right, so the next thing that we looked at, so just before we continue, we looked at verbs, and we looked at clients, and we looked at servers. The next thing we're going to be looking at is HTTP headers. So HTTP headers are key value pairs that give extra meaning to the web request or web response. Right? You can add your own headers for any information you would like to transmit. So in other words, if you want to basically transmit in a header something like your ESP32 ID, its MAC address, or if you've got some sort of key that you want to actually, some sort of security key that you want to transmit, anything that you want to put into the headers, you can put into the headers as a key value pair. But there are also some standard headers, all right, that you see very, very often, right? Some of them are things like the content length, and this is essentially the size of the payload that's going through. The content type, right? This is an important one. This indicates the media type of the resource. In other words, what is it that we're actually transmitting? Is it an image? Is it a HTML? Is it a CSS? This is important, otherwise the browser doesn't know how to interpret it, right? A content encoding is another one that you see sometimes for compression algorithms, and cookies, because everything in everything that we do in HTTP protocol is normally stateless, and that basically means that once a client has requested something from a server and then gotten a response, there is no memory left of what actually happened or who contacted what. So what actually usually happens is we usually write a cookie back to the client, and the client contains that cookie and then writes that back to the server, and then the server knows what the state is of the client, or who was talking to it last, or whether it was signed in, or whether it was authenticated, or whatever it was. Or maybe his favorite colors, whatever. Okay, so here are some important content headers, or some important headers that you see very commonly. Now, content length is usually added by our HTTP framework, and we usually do not need to set it directly. So whenever we actually build up one of these sort of requests or essentially response, we don't normally need to set the content length because it's done by the framework directly and it's actually transmitted for us. Another common one is authorization, all right, and this normally carries information about the security of the client, whether he was signed in or not. Content type tells the request or response what is being transmitted, whether it's an image, a JPEG, or a JSON, or whatever it is. And then sometimes servers protect themselves with an API key that goes in the header. So if we have a look at Google again, the one site that I'm sure we're all familiar with, and let's have a look at what's happening over here. And I'm just going to say, let's have a look at everything, right? And if I pick up pretty much any one of these, right, and I go to headers, we can see various different things. We can see, oh, look, the request method was a get. Okay, well, sorry, this is actually the general stuff. This is essentially the response headers. That's what came back. Let's look at the request headers first. So this is the request headers. The authority, the method, the path, the language. So this is how Google knows what your browser is set to, whether it's essentially English or something else. They've got various different other things inside here. Some of these things are standard, and a lot of them are just, some of them are just going to be sort of specific for Google. And then after we've got the request back, right, then essentially the Google servers are going to give us a response, and then they give us some other response headers. And these are also headers that they have, so you can see over here, the content encoding is gzip. So in other words, the information coming from the server is actually compressed. This is the content length. We can see how big it is, right? We can see what the content type is for this particular file that I've chosen. It's a JavaScript file. So various different other sort of informations that you can get from headers. Okay. Now, one of the more important one is the content type. And this is essentially a table that you can use so that you can actually set your headers, your content type headers, when you're actually trying to actually get information over to a client. So in other words, if you're hosting a server, or if you're hosting a website on your ESP32, and you want to serve some images or CSS or CSVs, you'll have to give it a content type. And you'll have to basically specify what that content type is. So in this particular case, you'll say, my header content type is text CSS or text CSV or an image or text HTML or whatever it is. And then what will happen is once it's transmitted, right, the client, which will be, in that case be the browser, will be able to look at that content type and be able to determine how to interpret it. We'll have a look at some JSON content types in just a moment. So what have we learned so far? Okay, so all web requests have a method that describes what's intended to do. We can see that. That's relatively important. Header information gives additional data about the request. That's quite important. And then the content types indicate indicate the data type or the type of data. Okay. The next thing that we're going to be looking at is response codes, right? Each HTTP request, right, that gets a response will have a code. Okay, and over here we can see what these things are broken down into. Anything from 100 to 199 for a response code is an informational response, right? We've all seen 404 not found. That's essentially an error, a client error. But you also get successful responses, 200, redirects, or 300. That's essentially if you move your site somewhere else, or if a site no longer wants to basically be called by HTTP google.com but wants to be called by HTTPS google.com, then what they'll do is they'll redirect you from HTTP google.com to HTTPS google.com. So that's how they basically do that. They give a response back in the browser saying that the client needs to redirect. Well, sorry, the server will give back a redirect response. Okay, client errors, we see those all the time when we basically look for stuff that doesn't exist anymore. And then every once in a while you might see this error come up, right, in 500 or something like that, basically saying that there was some sort of server error. Here are some common response codes. All right, so 200 is okay, 301 moved permanently and redirected. And then you've seen these guys before: bad request, unauthorized, forbidden, not found, and internal server error. So going and having a look at Google again, right, we can basically clearly see that under the general, we can see that this one was okay. And if we go to a different one, we should see that this one was okay. And if we went to something else, let's say, for example, /GPPG, All right, we can see that we get an error. This is a 404. That thing was not found. Okay. So a response code tells the client how the server handles the request. Okay. Right, so that basically is what we can say about HTTP so far. So I see that Amir's got a question. I'm just going to see if I can answer that quickly. So Amir asks, can I request a server for the content length, and all servers are automatically can respond on the request, or the server must be programmed to answer for that kind of request? I'm not sure I follow, Amir. So can I request? I think what you're trying to basically say is, can you basically redirect it as per content length? I wouldn't do that. Personally, what you should do is basically have a path and use different paths in your server to decide what you want to handle. So if I go back to the server over here, if you can imagine, right, that I'm basically going to create another one of these, and then I could put another path at the end. All right. Then once I've actually put that path in the end and give it a different handler, then that other handler will handle a different response. Okay, good. So, so Jason will help you out with that. Okay, so next, HTTPS. Let's have a look at HTTPS. A lot of people get very confused and get hung up on this, but as with everything, once you understand the basics, it's actually pretty simple. Okay, so we saw this before, where we actually have a client, a request, and a server, and then essentially a response. Now there's something else that we need to have with HTTPS. HTTPS, for HTTPS to be there, needs a bad guy. We need to basically have the opportunity for some bad guy to be able to listen in and sniff in on our network. Now, you'll be surprised how easy that can actually be. Specifically, if you're on a public Wi-Fi, such as Starbucks or something like that, it's very, very easy to monitor all the traffic that's going up and down. And of course, it goes across the network in clear text. So any passwords or any bank details or any health information or private information can be easily read, right? That's why we have HTTPS, because it stops that from happening. Okay, so now that this guy can see everything, what are we going to do about it? Well, what we'll need to do is we'll need to encrypt the data. Okay, so in order for us to encrypt the data, the first thing we'll need to actually do is we'll need to get some sort of negotiation between the client on the server to have an encryption key. Okay, now that is actually quite a bit of mathematics that happen behind the scenes there, and it's not something we really need to get in right now. The important part is the fact that the server has a certificate. Okay, and the server sends over the certificate to the client. Okay. And from that negotiation, I mean, there's a few other things as well. There's actually another server. There's actually another cert on the server. There's a client, a private certificate, and then there's this thing that it's handing over, which is a public certificate. And there's various different other things, but let's not worry about all of that. The point is they go through this whole negotiation. We send over the certificate, and the next thing you know, right, these things basically pop out this encryption key that they can now use to negotiate traffic with. So this one basically gets an encryption key, and this one gets an encryption key. All right, and now that that's encrypted, what will actually happen is when the client wants to actually send information, it basically encrypts it first, then it sends an encrypted payload over the network to the server. The server then decrypts it with that encryption key, and when it wants to respond, it'll basically encrypt the response, and then the server will decrypt it. So this poor guy now, looking at the incoming request and the response, is just looking at gobbled, gobbledygook. He doesn't actually know what he's looking at because it's just encrypted data. Okay, so here are some things which are of interest for us in terms of ESP32 development. The ESP HTTP client takes care of our SSL connection. Isn't that cool? We don't actually have to do anything special for it. It can negotiate a key. It encrypts the request and it decrypts the response. So this is essentially obviously from the client's perspective. Okay. So that's all cool. So then why do we have this cert PEM option in our client config? Because this actually confuses quite a lot of people. What is this guy doing in here? All right. Well, there is two things that a certificate will give us. The first thing is it'll give us encryption, but the other thing that it actually gives us as well is it gives us validation to the server. Let's have a look at a situation, right, without actually worrying about the validation and what can actually happen. We have the same situation before where we actually have this bad guy. He's reading traffic, but now all of a sudden it's all gobbledygook. So he comes up with a plan. And his evil plan is to basically say, well, you know what? Right, I'm just going to basically mark this over here. It's going to say, I know that this particular server over here is actually just sitting on an IP address, 192.168. blah, blah, blah. Okay, cool. All right, so what I'm going to do is I'm going to fool the local network. I'm going to fool, oops, sorry. Let's just go through that again. I'm going to fool the local network. And what I'm going to do is I'm going to replace, right, that IP address with my own server. So now that anybody who's basically, this client over here who's talking, right, over the network thinks that I'm actually the bank, but I'm actually not the bank. I'm essentially this evil rogue server. So he basically throws away the original server on the network, and now he's basically got his own server there. This is also commonly known as like a man-in-the-middle attack. Okay, so now we don't know this, but we're actually talking to the bad server, all right? And he's got a page that looks exactly like our internet bank login page. So when we actually log in from our browser to that particular site, we see an exactly the same looking page, and now we can enter our credentials, and guess what? He's now got our username and password. Of course, we can basically hand over the cert. We're going to validate that cert, and everything is still cool, because essentially we're going to go over this encryption and decryption, but of course we're dealing with a rogue server over there. So what's the solution? Well, luckily for us, there's actually a built-in solution, because certificates are built in chains. Right? And the certificate that the client receives from a server will be part of that chain. Right? So essentially, remember that when a server gives us a particular certificate, right, it sends it over to us, and it is part of a chain. Right? Now, the root of that chain is issued by a certificate authority, and there are a couple around, right? VeriSign and various different others, you know. And these guys are in charge of basically making sure that they dish out certificates that are valid to valid clients. Now, your browser comes loaded with all the root certificates given out by certificate authorities. If your browser does not recognize the certificate, you get the security warning, and I'm sure you may have seen this. See, it says HPPS, but it's actually crossed out. And it's basically saying there is some problem with this thing. You know, don't continue with this. And we'll actually have a look at an example of that in just a moment. But before we do that, one thing I'd like to show you is back to Google. All right, we don't need this anymore, so let's close that. Okay, so over here we see the certificate over here, right? And what I'm going to do is I'm going to click on that, and I can have a look at the certificate. All right, so this is the actual certificate that we have over here. And I can look at the certificate path. And here is the chain. So there's this thing called a wildcard certificate. It's basically gmail.google.com or gmaps.google.com. So they're using a single certificate for all of their subdomains, right? All of the domains that come before them, right? And then part of that chain is essentially this GTS Certificate Authority 101. And then above that, we've got this Google Trusted Service, okay, global sign root. So essentially, this is essentially the root of the chain. That's the certificate authority. Now, if I go into my certificates over here in Windows, I can go and have a look at my root certificates somewhere around here, trusted root certificates. And these are all the root certificates that you will see in here. And inside here somewhere, you'll probably find Google. Somewhere in here. There's GoDaddy ones, there's all sorts of different ones. Google Trust, somewhere in here. It must be in here. So my eyes are not just picking it up right now, but if I looked for a bit longer, I probably would find it. But in any case, right, this is how it matches, and this is how it knows when it actually comes through, right, that that particular certificate is valid. So a bad guy can't just make a sort of any arbitrary certificate. He has to basically give a valid certificate, and he can't do that because he doesn't own the certificate chain. Okay. Right, so this is the reason why we basically have that particular certificate in the ESP32 structure. Because what we can do then is we can basically store that particular certificate inside our ESP32 and validate that we're actually talking to the right client, to the right server. So validating a cert on the ESP32 client, we don't store all the root certificates in the ESP32. That would be a waste of space. Okay. We just get the ones that we need and use it in the configuration. Okay. If a server gives us an invalid certificate, the ESP32 throws an error and will not connect. Okay. Now, a couple of things to note, right? If you want to create an HPPS server for your ESP32, you need to basically go into the menu config, and you need to go into component config HTTP server, and you need to say max HTTP request header length is 1024. It's usually set to less than that, but if it isn't, then it doesn't actually have enough room in its headers to basically negotiate the certificates. So you need to make sure that that's there, okay? Then essentially the next one you need to do is you need to enable HTTPS server, okay? And if you don't do this, right, then you generally aren't able to compile. It won't actually recognize your libraries. And then what we can do, the next step we need to do is we actually need to generate a certificate. Now, when we're doing it on our own local machine, we can't get a valid certificate, right? We can do that once we actually get a proper domain, which we might sort of have a look at next time if you guys are interested in doing that. But for now, right, what we'll be doing is we'll basically just be creating our own private certificates that we can essentially test HTTPS with. And we can use OpenSSL to do that. If you're on a Windows machine, you'll need to basically download the OpenSSL and just install it. If you're on a sort of a Linux or a Mac, this comes pretty much out the box. You put in this thing and it's going to give you two certificates, a private and a public certificate, and then you can use those inside your applications. Okay, so let's have a look at an HTTPS client. So here is an HTTPS client. Okay. And over here we can see that it is exactly the same as what we just had before. So in other words, we're doing exactly the same information, we're doing exactly the same thing. The only difference now is we've got the cert payment. We're basically injecting this cert payment here. So you might be wondering, you know, how the hell did I get this certificate in there? Right, so I'll just basically go through that very, very quickly. You can see over here that I've got this particular instruction over here. It's essentially calling the assembler language and getting a reference to a particular location in memory, right, where it's called underscore binary worldtime pem.start. And the way that this works is we have the capability of actually flashing or putting into memory certificates, okay, like this one over here, worldtime.pem, and we always basically say underscore binary underscore, and then we say whatever it is, and we replace any sort of funny characters like commas or dots or dashes with an underscore, and then essentially underscore start to suffix it. So this is a prefix, that's a suffix, that's the name of the file, and all its special characters that are not alphanumeric are replaced with an underscore. Okay, then in our CMake lists, we can basically say embedded texts, and then we can actually just specify where those particular files are, and that will inject it straight into our code. So that's how we can actually get those certificates into our code. So coming back to our HTTPS client, we now have this world cert certificate, which looks like this. It's a bunch of essentially gobbledygook. Okay, and it's going to basically put that into our client configuration. All right, so what I'm going to do is going to go to main quickly and just comment out this HTTP server, and now let's have a look at this HTTPS client. And let's go ahead and flash that. Okay. So now it's basically decided to take some time. Just give it a moment. Here it goes. Now notice just one thing. that you'll notice that this is now looking at HTTPS worldtime.com. They actually have both addresses, yeah? They've got a HTTP and an HTTPS. So we can see we've got an IP address, okay? And now we can see that we've got our payload. Okay, awesome. So that worked with HTTPS. Now, because we've actually specified a certificate, all right, if I go in here and I say, all right, I'm not interested in looking at this URL, I want to look at that URL. All right, let's go ahead and try that again. All right, here we go. And let's have a look and see how it responds. Okay, so connecting, getting an IP address, and now it's telling me, won't connect. Sorry, something wrong. That certificate does not match that URL. All right, and that's why it's failing. Okay, so this is how we can protect our client to make sure that we're going through to a valid server, and nobody's trying to basically fool our chip into going into an incorrect server. All right. The next thing I want to show you is essentially the HTTPS server. So I'll just go through to main, and I'll just basically comment this one out, and we'll have a look at the HTTPS server. And what we can do is this: we can have a look at this server, and I can say, all right, select for compare, and then we'll look at this HTTPS server over here. Compare with selected, and what you'll notice is that it's awfully similar. Over here the header is slightly different. You can see that for the HTTP server it's HTTP, and this one is essentially HTTPS. Okay, I changed the message slightly from hello world to hello secure world. Fair enough. I've changed the signature of that. That's pretty much okay, a little bit different. And this is where the big differences come in. So this handler is the same. That's not very different. This is different. So you can see this is HTTPD SSL config as opposed to HTTP config. And this is HTTPD SSL config default. And over here, we can see, right, that I have these certificates over here. So essentially we've got the start of the certificate and the end certificate. I could have done this in a different way. I could have actually just gotten the string length because they are basically text, and then but it actually requires that I've got +1 because it actually, for some reason, it looks at the null terminator or something like that. But in any case, right, we've got this certificate over here. And what we do is we set the config to this particular certificate, and we set the certificate length to the beginning minus the start. So that basically gives us a certificate for our public certificate and our private certificate. Because if you remember, what I said is that if you have a look at that command that you run, you get 2 certificates out, and you need both. The private one's going to be kept within the ESP32. The public one is going to be also kept within the ESP32, but given to the client when they request it. Okay, so let's have a look at this. So just make sure that this is saved. So let's have a look at HTTPS server, and let's go ahead and flash this guy. So coming back here, right? So all of this is doing is basically just getting the certificates out of memory and then assigning them to the cert plus the length of that cert. That's what's required for both the CA cert plus the private key. So the certificate authority cert, which is the public certificate, as well as the private key. Right, and the rest is pretty much exactly the same as we've looked at before. Okay, so let's have a look and see how this responds. So I'm going to bring up a browser. Just wait for this thing to finish. Okay, so we've got a connection, we've got an IP address, we're listening on 443. See? All right, so let's go through to this address. So I'm going to go through to this address, and bang, nothing happened. Why? Oh, well, quite simply because essentially we went through on HTTP, not HTTPS. So let's go ahead and go through to HTTPS. Okay, so we can see hello from secure world. And we can see this is not secure. Okay, we can see that we're going to get this error. First time you run this, actually, you actually see that whole sort of warning come up and says, are you sure you want to continue to this? You know, you sure you want to go through to safe, etc., etc., etc. And that's because it's not able to validate the certificate chain. So this is something that you normally wouldn't worry about in development, and then in production you would have a proper DNS with a proper certificate, and then you would basically push those certificates, or you would basically use those certificates that you get from a certificate authority, such as OpenSSL or VeriSign, and you put them in here, and then that error doesn't occur anymore. Okay, so moving on. So what have we learned so far? Okay, for HTTPS, the server and the client negotiate a key with a certificate. All right, ESP HTTP client takes care of HTTPS connections. If you are not too worried about, if you're not too concerned about the fact, all right, that somebody's trying to sort of spoof your microcontroller in saying that you're going through to an incorrect server, then this is not something you would need to worry about. But if you are, then you can just add the certificate. All right, an ESP32 client can validate a server by passing a certificate to the config. One thing I actually wanted to show you quickly, let's just do this very, very fast. Just take a step back because I forgot to do this before. So if I have a look at this particular client over here, you might be wondering, how the hell did I get the certificate? This binary real-time pem.start. So if you recall, if we go to that particular web address, right, you have the ability to look at those certificates, and you can just look at that certificate, and then you can actually get those from here. And what you can do here is go to the details, and then you can just copy it to a file. There you go, next. And what you actually want is you want the base 64 encoded one. You don't want this one. This one is essentially, the certificate is binary, but this is essentially base 64 encoded. That's that ugly text we were looking at early on. That's what you want. And then you just go next, and then you can just put it into a place, and then you can get it. Now, one thing to note is that not all certificates are created equally. Sometimes they don't work just because of the way that they were created. And, like wildcards don't work. This certificate itself, actually, I struggled to get that one to work. So what I do is essentially just go up the roots chain to the next one up. And this one usually works. So, if you are creating your own certificates, then that should probably work fine. But the ESP32 obviously has got some limitations in terms of the type of certificates that it can create, in terms of its size, and in terms of how it's put together. So then just use one up higher on the certificate authority chain, and you should be fine. Okay, and that's the command that will basically create the private and the public cert. It'll create both of them for you, and then you can essentially use them for your HTTPS server. All good. All right, let's continue. Okay. Cool. So, next. I sort of see that Jason, just by the way, I see that Jason's been sort of handling a lot of communication. Jason's a very, very close friend of mine, and I really do appreciate his help on this, so thank you. All right, next. Right, dealing with data. So we've basically looked at essentially connecting with HTTP. We looked at connecting to a server with HTTPS, both from a client and a server-side perspective. Let's go have a look at essentially at some data. Right, so one thing that I note that I sort of neglected to tell you, right, in terms of this particular client that we were looking at earlier on, it's a very simple client. The problem with this particular client is that it doesn't work for big payloads. This actually only works if you've got a very small payload. And if you have a very big payload, you're just going to get the last piece out of it, right? So this doesn't really work for big payloads. So generally what we need to do is we need to chunk our data. We need to basically receive it as chunked data. Okay, so let's have a look at this. We've got a server over here, and it's got some new data. Okay, now what we'll do is we'll basically specify a buffer, and we'll have an index. So this index is sitting at 0 on the location of our buffer, and this is just essentially a byte array or uint8 array. Okay, and then what will happen is that our server will give us some data. It'll give us a chunk of information. Okay, and the first thing we'll basically do is we'll have a look and we'll say this new chunk has been passed to us, which is cool, but it doesn't fit in our buffer. So the thing that we need to do is we need to increase the memory size. So we need to basically say this is not going to fit in 3 bytes. Let's go ahead and actually increase that to something a bit bigger. Right, then what we can do is we can move the data into the memory at the position of the index offset, this position here. So that lot goes into here. Okay. Now we increase the index to the end of the data. So this index now goes to that point there. Okay, so there's your null terminator. Okay, cool. Now we get the next piece of data, the next chunk, right? So you can see it was new day that came through first, and now we got the rest of it, ta, with an exclamation mark. A new chunk has been passed to us. It does not fit in our buffer, so increase the memory size. Move the data into memory at the position of the index offset. Increase the index to the end of the data. And you just rinse and repeat, and that's essentially how you can capture a whole bunch of data. Okay? All right. So having now said that, all right, let's go and have a look at this particular piece of code over here. All right. This code over here, right, starts life off at this particular function over here, HPPS chunk client. You can see over here, right, that I've created a structure. Right, this structure is really, really simple. It's my structure. I created that. And if we're going to have a look at the definition, we can see that it essentially has 2 members. It's got a pointer to a body, which is just a location for the actual body of the incoming information. And it's got a content length, which is just an integer. So the first thing we do is we basically say, all right, let's go ahead and create the structure. And I need to initialize it, so I'll basically give the body a location in memory. I'm just giving it 10 bytes. It doesn't actually matter how much you give it at this point in time, because we're going to basically increase the memory to the incoming chunk in any case down the line. But you can make that 10 or 1 or 300, doesn't matter. And then essentially what I'm going to do over here is I'm going to say content length is equal to 0. And that's actually the index. Okay, now over here I'm just basically cleaning that structure out. Okay, fair enough. All good. Okay. Well, no, I'm not clearing the structure. Sorry, my bad. I'm cleaning out the body. I'm making that body, this one over here, completely empty. So I'm basically filling it with nulls. All right, you saw this before where we basically get the cert. And you've seen this structure before where we basically have this client config. And the difference between what we saw before and this one is that this one has got 2 new things added to it. It's got this event handler and user data. So what we'll do is we'll basically take this data received, this structure that we've just created, and we'll assign it to user data. And then essentially we'll look at this get device data handler over here. So this is a function that looks like this. Okay. And the way that this works, when we actually assign this particular method onto the client config over here, it's going to be called multiple times for every single thing that happens on, internally. So when it connects, it's going to basically fire this thing over here. When we get a chunk, it's going to basically fire this thing. When we get a header, it's going to fire this thing over here. When we disconnect, it's going to basically fire this particular function. So the way that we can actually assert what it's actually, or the way that we can figure out what's actually happening or where we are in the process is we can actually use a switch. And at this point in time, I'm only interested in just this one switch on event, on data gotten. Okay. Now, what's going to happen is as follows, right? The first thing we're going to do is we're going to reallocate, we're going to increase the size of our memory of our body. Oh, you want to know where that comes from, this data receipt body? Well, what we did was we basically just took the user data out, okay? And we've got that now as a pointer. So just once again, we passed that in over here. We created this over here. We passed it in over here. We get it out into this function over here. So we've got it locally in memory. Now, what we can do is we can basically say, all right, let's reallocate that size of that body to equal to the data received content length, how long is the actual data, plus the data length that we just got in, right? So just coming back to here, let's just go back here. So this is what we've done. We've got this chunk, and now we're looking and basically seeing how big is it, and now we're reallocating it a new size, okay? Once we've reallocated it a new size, okay, we can basically check and see if we've actually run out of memory, right? Then what we can do is we can move the event data, which is essentially the chunk that's just come in, for the length of that data, and we can move that into our receive buffer at the index of this particular content length. So what's happening there is essentially I've got my content length at 0 at this initial stage, and we're moving that data in. So just one more time, we've increased the buffer size, and now we've essentially still at 0, okay, and we're moving that data in. So this is 0, we're moving that data in. Right, now what we can do is we can basically increase our index to the length of the data that's just come in, okay, and then essentially we can just give it a null terminator at the end and rinse and repeat. Okay, so in other words, what's going to happen is we're going to get lots of chunks. We're going to keep on basically following the same process over and over and again. And eventually what will happen is this thing is going to quit. So when we finish performing, then we're going to come in here, and then we can finally print out all the data. Okay, so let's have a look and see how this works. So this sort of thing becomes important if you've got a large payload. One thing that you probably want to keep in mind is the fact that you are limited in terms of memory, and especially if you don't have things like PS RAM. I'm not actually running a PS RAM chip at the moment. I'm just running a normal sort of room chip, so it's only got a couple of megs on the stack. It's like 250 megabytes, and you got to be careful that you're not going to run out of space. So be careful about how much you download. Sometimes you just want to basically write it into a file directly, then you wouldn't have to worry about it. But there are various different strategies that you can use. But at this point in time, this is essentially a fairly decent one that you can get a lot with. So I'm looking for google.com, so I just want to get the home page, and there it is. You can see all of the various different things coming down from google.com. Okay, so and you can see that's HPPS. In this particular case, I'm actually using the Google cert as well. So so obviously if I were to go to bing.com, this will fail because I've actually specified the cert. Okay, but what also is very interesting, right, is if I do not specify the cert and I actually then go to bing.com, then it will work because it will handle it automatically for us. Okay, right. So I hope you guys are doing okay there. Good. I hope it's interesting so far. Let's continue. All right, so we looked at chunking data. Okay, so we looked at the client. Now, most of the time we're not going to be looking at HTML. Most of the time when we're looking at stuff, we're looking to look at JSON. Okay, and not my friend Jason, actual data structure Jason. Anyway, JSON is the most widely used data structure on the internet. Okay, and with the IDF, we've got a built-in CJSON library. Okay, to send data to the server from ESP32, we create a CJSON structure like this. Okay, then we can add data to it, and here we can see we can add a string to the object. Right, so over here I'm basically saying I want to add first name. The key is first name, and the last name is John. And then once we've done that, right, we can also use the CJSON print function to create a string. So that's basically what we're doing at the end over here. So char message is equal to CJSON print, and this is actually what it's going to give me. So what we need to do in total completion is essentially also make sure that we set the content type header for application JSON. Then we send the payload as a string, and then we need to clean up after ourselves because this stuff's expensive. So we delete the CJSON structure, and then we free that string. So it's our responsibility to get rid of both this as well as this. Okay, now you can see there's a number of things that you can do over here. You can add a string to object, you can add a number to an object, you can add an object to an object, you can add an array to an object, you can add an etc, etc, etc. You get the point. Let's have a look at a demonstration of that. Okay, so this is a CJSON server. All right, let's have a quick walkthrough of what's going on here. Okay, so we basically create the payload where we add these two key value pairs, right? First name and last name, right? Then we add the age, which is a number. Now, all right, we've got a bit of a pet theme going, so why not actually go ahead and add an array of pets? Okay, so what we'll do is firstly, we can see that we create this array onto the payload, and then what we'll do is we'll actually create another object called pet1. You see, that's not connected to anything just yet. And then what we can do is add an item to an array, and we'll basically connect that new object to this array. Then we can add some items to that pet1, and then we'll do the same thing for pet2. All right. Then we'll go ahead and print that out and create a string. Then we'll delete the CJSON object. We'll print it out, and then this is important. We'll basically set the content type. You see. And usually you can say set content type, but this is a shorthand, set type. It's a helper method because essentially setting the content type is very common. So what is it we're going to set it to? And we're going to set it to application JSON. And then we can basically send that response. So the rest of it is exactly the same as we saw before. Right, this is using an HTTP server, not an HPPS server. All right, let's go ahead and try this out. Okay, yeah, I agree that whole naming convention is not, you get your head in a twist. So there's a comment on the comment saying, you know, that file name is not very intuitive in terms of how you basically name the certificates or essentially what you want to inject into it. Specifically, what he's talking about is this thing over here. No, it's not very intuitive, but once you get the hang of it, it's not too bad. Okay. All right, so we're connecting. And connected. All right, so there's IP address. All right, let's go have a look at this. I'll just basically go to a fresh browser somewhere. All right, and we'll go through to this address. And we have some JSON. Pretty straightforward. Okay, and you can get pretty complicated. You can basically, you know, in here you can have arrays and arrays of objects and objects of arrays, and you can do whatever you like. You know, you can pretty much build any type of JSON structure you want using the CJSON library. I find it actually quite easy to use. It takes a little bit to get your head around it, specifically if you want to actually do things like loops. But once you've actually gotten your head around it, it's actually very straightforward. Okay. So that's essentially handling JSON. Let's get to the next part. All right, so we can also parse JSON. Okay, so very often, like from a server perspective, right, if the client is giving us JSON, then we want to parse that. And we can do that also using the CJSON structure, and we use the parse function. Okay, and then essentially we can get items, like we get this, use this CJSON get object items case sensitive to get a particular element out of that JSON. And then we can use things like the value string or int to get the actual number or what, you know, the actual string itself. And there's various different other overloads and methods that, well, not overloads, there's various different other properties that you can use to basically get various different types, such as if it's a double or whatever. All right, let's go ahead and have a look at that. In fact, before we look into that, it would probably make more sense if we actually go and have a look at these tools, because now we can actually see how these things actually work, because these tools will actually demonstrate that for us. There are two tools that I use that I find really very good. The first one is Postman. Postman is very good for acting as a client. So this is essentially what I primarily use for a client. You can send pretty much any method you want, whether it's a get, a post, whatever. You can display JSON quite nicely, as you can see over here. It's easy to set headers. You just go to the headers section and you can put in a whole bunch of key value pairs. It's very simple to use, and it's free, which is my favorite price to pay. And it's got a bunch of other information in it as well, like you can see the status code, the 200, you can see the time that it's taken. You know, there's various different other things which are quite useful here, right? So what I'm going to do, actually before we do that, let's have a look at the next one. Macoun. So Macoun is a very good server. Now Postman does actually have the ability to actually serve posts as well, or basically act as a server as well. But I prefer Macoun to actually acting as a server. I think it's really, really cool. It's very easy to use. You know, it listens on any port that you want, listens to pretty much any verb, right? It's also free, and it's got some pretty interesting advanced features. So let's go have a look at this. So the first thing I want to do is actually bring up Postman. And in fact, while that's basically coming up, I'm also going to bring up Macoun. So that is taking its sweet time to load. All right. While that's basically running out, let's try and see if we can actually get this next one loaded. Okay, so what I would like to do next is I would like to basically just load this one. And this is going to be a CJSON post as well. So essentially what we're looking at over here is essentially parsing JSON. It's a server that's going to parse JSON and actually also send it out as well. Okay, so let's just walk through this very quickly. We can see over here that we're going to go ahead and actually get a buffer from our incoming request. Just by the way, just to orient you, right? This is essentially the same server we've looked at all the time. This is essentially the handler. And once we actually come into the handler, the first thing we're going to be doing is just to make sure that we've got some content in there. And then we're going to create some space for that content, which is what this malloc is doing, okay? And then we'll basically fill that buffer up full of the content of the incoming data, okay? Then what we'll do is we'll basically take that incoming data, which is a JSON string, and we'll pass it. And that'll basically give me a CJSON object back out. And then from there, all I need to do is just basically say, let's get that message out of that thing. And then what we can do is we can just allocate some space for the response string, and then we can print it out. All right, let's have a look and see if we can actually get this to work now. Oh, come on. Really? Oh, here it goes. Finally. Okay, it looks like we finally got it up and running. Okay, so what I'm going to be doing now is have a look at this. I'm going to be sending from my IP address. All right, so if I have a look at what my IP address is, coming back to here, 192.168.0.116. Okay, I could also use localhost, but I'm just going to use this for now. Okay, so what I want to do is I want to send to this particular address, okay, just whatever, let's just use localhost, just make it simple. Localhost, and we'll need to give it a port. Let's go for port 2020, okay, just so that we've got something to match on this side. Okay, and then what we'll do is basically say, all right, let's go to the body, and we'll put in the message, hello world. Okay, so we can see that we're going to post, okay, a raw message of JSON, and that all looks good. Okay, and then over here what we'll do is we'll basically say, all right, I want to create a new server. You just go ahead and add a new one like this, and we can basically specify what it is. Let's delete this one. All right, and then we can say whether it's a post or a get that we're actually expecting from the server end. We can put in the path if we have a path, all right? And over here we can basically say what it is we want to actually respond with. So if I go ahead and actually send this message now, nothing's going to come back. Why? Because we haven't started our server. So let's go ahead and start our server. And let's try it again, send. And we see that the message is okay. I see that, okay, so, okay. Sure. All right, good. So what I was, just to recap very quickly, right, what I've got over here is I've got Macoon over here, which is essentially a server. I've basically given it a port. I've told it that it's going to be a post. And I've also said I've put in here some sort of response. And then essentially I've got over here the postman acting as a client. And then essentially I can send that. And then you can see Macoon is responding. So this gives us a really, this gives us a very interesting sort of testing suite between a postman, or as acting as a client, and Macoon acting as a server. Okay, so now the thing is, all we need to do is basically, instead of talking from this one to this one, we can now use either one to talk to our chip. If we want to basically test our server, we'll use postman as a client, and if we want to actually test our client, we can use Macoon as our server. Right, so what I was going to do now is I was just going to basically show this one over here. This is an interesting one because essentially we're both parsing JSON, we're getting a buffer with a message inside it, and then we're trying to basically get the response string out of it. Okay, so just to recap, because I'm not sure how much you guys heard, we can use this CJSON parse function to basically get a CJSON object out. Then we can look for individual items, and once we get that item, we can then use this received message value string to get the string out. And you can see that we're just printing that out. Okay. And then what I'm doing in this case is I'm basically adding a response item to this incoming JSON that I've just got, and I'm basically sending it back out. Okay. So let's have a look and see how this actually works. So because this is essentially a server, the thing to do is actually use Postman. Now, the wrong thing to do, and I've seen this lots of times, is basically come in here and say, all right, let's go have a look at localhost. Because if you're posting to localhost, you're posting to your local machine, not your ESP32. So we need to actually get the ESP32 IP address. Okay, so let's go ahead and run that. All right, so it's compiling. Okay, so we have an IP address. So we can basically hit that server now. So we'll go ahead and hit that server endpoint. Okay, and we'll send that, and it comes back and it says, message says hello world, right? Received your message with hello world. Okay, let's go ahead and actually change this to something else. Let's go 111 and send that. All right. Actually, I had a crash there. Never mind. I made a mistake somewhere. All right. I thought I actually put in a bar, something to actually guard that, but obviously not good enough. Let's try and actually send an empty string. That's what I was expecting. Okay, so it's invalid JSON. Okay, so you can basically see that over here, what I've done is I've said, right, that if there's no message received, then you can essentially just check it like that. I'm also looking for this thing called message. For some reason, when I try to actually put in an invalid one, then it actually bombed out. Let's try and actually just change that to something else. And send that. Okay, the message is missing, with the bad spelling missing. And we come in here and we say message. We send that. And we can see that we get a valid response. So you can check to see whether or not you got actually what you expect to see on the JSON just by checking that. So, you know, so we can basically see over here, we say, right, get that object. If it's null, then essentially don't even bother going in here. And that's how essentially you can parse through that JSON. Okay. Right, back to the slides. So there's the JSON server. All right. So we saw that Postman and Macoun working together. We saw ESP32 JSON server with Postman using Postman, or Post using Postman. Now let's have a look at a client using Macoun. Right, so this will be the last demo. So we'll have a look at this JSON client. So very quickly, this is a very simple little client where we're actually going to create the object. We're going to then go ahead and actually create an item on that object, which is basically going to be the temperature of 25 degrees. We then print that particular object. Okay. And then, of course, what we can do here, and this is where it gets interesting, is we can basically say, all right, set the header for the content type is application JSON. Right, and then we can basically say set the post field, and this is going to set my body to this message payload. Right, and then we can perform. So that in itself is going to actually kick off a request with the JSON of the temperature is going to be 25. And then what we can do is we can basically have a look at the response, and we can read the response, client read. We can then basically parse that payload. And over here we can basically get the object out of it, and I'm looking for a key called message in the payload. And then if I do have that, then I can essentially just print it out on the console. Right, so let's go ahead and actually compile this one. All right. It's just a bit laggy for some reason again. Obviously lots going on.
And it's raining.
Okay, so what I think is happening is that when I compile, it's just using up that much more CPU, and then it's competing with OBS and everything else like that, plus Macoun, plus Postman, and it's just basically just giving me a hard time here. So just give it a second for it to actually just catch up, and then we'll continue. We can see that we've got this, the IP address. Okay, so let's have a look at this. Right, so what I'm going to do is I'm going to stop the server, and I'm going to reset the chip. Okay, and what you'll notice is that it's going to get an IP address, and then it's not going to be able to get through. It's going to fail. And this is typically what you would have if you don't have a server to help you out. So what we'll do is we'll change that by basically starting that server. And if you have a look and see what I've done here, is you can see that I'm going through to my IP address, :2020. Again, people actually often put localhost accidentally in here, and that's never going to work. And you can see that the method is a post, and then again you've got the content header, and we're basically setting the post field. So now that the server is up and running, let's go ahead and reset this chip and run that application again. Okay, and you can see that we've got this okay. Let's go ahead and change that to okay. How are you? Question mark. And I'll reset the chip again just to run the same application. And it says, okay, how are you? Now, what's really cool about Macoun is if you basically have a look at this over here, you can actually see all the various different requests coming in. You can see the response that Macoun has given out. You can see the status code is 200, the content length, which was automatically set, the content type, which it's automatically set in our case, and this message. But you can also have a look at the request, and this is very valuable because now you can see what the ESP32 was giving us. And over here you can see any and all headers that you might want to see. plus you can see over here the temperature was 25. So between Macoun and Postman and this newfound knowledge, I'm hoping you should be able to do the next bit. And this is essentially the last bit. So this is essentially just like a little exercise that you might want to try out. You can go to something like openweathermaps.org API. And what that's going to look like, let's just push that up here. That looks like this. So you can see over here we've got various different APIs. You can get current weather, hourly forecast, and so on. And what's really cool is if you have a look at things like pricing, right, you'll notice that if you're essentially a hobbyist, even if you're using this even commercially, you can get up to 1 million calls of this API for free per month, and you're limited to 1 per second. So, 60 calls per minute. So chances of you running out, over exceeding that with an ESP32 is not very high. You'd have to use a lot of ESP32s to exceed that. But what you can do is you can sign up for free, and you don't have to put any credit card information in, okay? And then you can get an API key. And, once you get your API key, right, what's nice about this particular one is that you can create, so I don't have to worry about it. I can actually create and destroy these API keys as I want to. So once you've got your API key, right, so I'll just basically store that somewhere. Just put it on Notepad. Okay, then what we can do is we can have a look at these APIs. Let's go have a look at this API document. And you can see over here, there's various different ways of calling it. Okay, so let's go ahead and grab that. And we'll put that in here. And we'll replace the API key with this lot over here. And then over here we can replace the city with, let's say, for example, let's go for New York. And let's go ahead and put that in Postman, because that'll format it nicely. And this is going to be a GET request. And we can send that off. And we can see the weather at the moment, the latitude, the longitude, and the weather. It's even given a sort of indication to an icon. The temperature. This is obviously Fahrenheit. And there'd be ways to basically set it for centigrade if you're more interested in that. And what you can try to do now is you can basically look at this service, or you can look at various different other services like Google Search API or Google Maps API. And really, if you understand the basic principles of you need a verb, which is going to be your get, your post, your whatever it is, you need your headers, and very often you'll put keys in your headers. Over here they put it inside the actual URL, but very often they put it inside the headers. So you need some verbs, you need some headers, you need some query strings sometimes, you need a domain, you need a path. And that's pretty much everything that you need in order for you to be able to work with HTTP protocol. So yeah, that was it. So I am essentially 20 seconds behind you on the clock in terms of, or 20 to 30 seconds in terms of delay. So I am going to ask you for any questions. And yeah, please go ahead, ask any questions. I'll basically be on here for another sort of 10 minutes or so, 10 or 15 minutes. And then if you've got any questions, that's fine. Otherwise, I hope you've enjoyed it. I hope you learned something. I hope it was valuable. If you want to have a look at the, source code, you can see underneath the link there's the repo. If you're not used to the IDF, you may need to look at my course to basically get familiar with the beginnings of it. But yeah, that's the repo over here. And there's the certs, there's all the various different modules. And there's your main, where you can basically just comment out whichever one you want. And I hope that was interesting and useful, guys. Yeah. Yeah, let me know if you've got any questions. I'm going to have some tea.